Okay, so what I'm going to do now is start some A2 integration. So earlier on in this second year, you have met a bunch of new rules for differentiation. Because integration is the reverse of differentiation, anytime there is a differentiation rule, there is a corresponding integration rule, which is the reverse of that. So all I'm going to do today is give you 6 basic, I suppose, 1 mark integration rules, one of which you know already. So as you should know, if y is x to the n, dy by dx is nx to the n minus 1. The integration result, which is the reverse of that, which is what we did last year, is that if you integrate x to the m, you get 1 over n plus 1 x to the n plus 1 plus c. And it's worth bearing in mind this rule does not work when n is minus 1, because then n plus 1 would be 0 and we cannot divide by 0. Next rule. So we know and love that if you differentiate e to the x, you get e to the x. Because integration is the reverse of differentiation, integrating e to the x means what formula differentiates to give e to the x? Well, it's just e to the x, except we now need a plus c. We've also done a rule of differentiation where we differentiate any base to the power x. So a to the x differentiates to give ln a times a to the x. So consequently, we can now integrate a to the x. So by integrating a to the x means find a formula which differentiates to give a to the x. Well, you're going to need to cancel out the extra ln a in front. So rather than multiplying by ln a, we will divide by ln a. So a to the x will integrate to give a to the x over ln a plus c. Next basic rule of differentiation, ln x will differentiate to give you 1 over x. So you might think the next thing I'm going to do is now give you a rule for integrating ln x, but I can't. Integrating ln x is very tricky. We will come back to it later on in the course. But what I can do is do the following. Because ln x differentiates to give 1 over x, it must be the case that 1 over x integrates to give you ln of x. And this is now how you would integrate x to the power of minus 1. So this rule first rule doesn't work when n is minus 1. X to the minus 1 is 1 over x. It integrates to give ln x, except there is a problem. The problem is ln x is only defined if x is positive. ln x is undefined if x is negative. Now, there is a solution to this, which is the following, which is let's make x positive so we can do ln of it. And the thing that makes x positive is taking the modulus. So consequently, that's how we integrate 1 over x. It integrates to give ln mod x. The modulus sign is only actually important if the values of x we are using are negative. If the values of x we're using are positive, that can be missed out. And then 2 basic trig integration rules. Sine differentiates to give cos x. So consequently, cos x integrates to give sine x plus c. And cos differentiates to give minus sine x. So to integrate sine x, you've got to think what will differentiate to give you sine x, or the answer will be minus cos x plus c. And it's worth bearing a note that those 2 rules only work if the angles are measured in radians, because the differentiation results only work in radians. There's one kind of extra rule which we'll use all the time. It's kind of barely stated around for integrating more complicated functions. So this looks horrible, but all we're saying is if you're differentiating something made by taking one term and then adding or subtracting another term, you just integrate the first and integrate the second and then add or subtract. In addition, if there is a number in front of the formula, that number just stays in front and you integrate the formula. So if there's a b in front of the g of x, that stays in front and then you integrate g of x. So guys, what I think I'm going to do is I'm going to perhaps go through these three examples. Well, I'm going to go through one, then you try one. I'll give you a minute to think about it and then unveil it. So the first thing I'm going to integrate is e to the x plus x squared. Well, according to my previous rules, e to the x we can now integrate and it stays the same. X squared, as of last year, integrates to give a third x cubed. And if you're integrating two things added, you integrate the first, integrate the second, and add. And because it's an indefinite integral, you should put a plus c at the end. Go on, folks. You try the one on the right. Here you are. 2 to the x integrates to give 2 to the x over ln2. 1 over x cannot be integrated by writing it as x to the minus 1 because you can't divide by 0. 1 over x integrates to give ln mod x plus c. Next one, the integral of 2 sine x plus 4 cos x. Well, sine integrates to give minus cos, so 2 sine x will integrate to give minus 2 cos x. Cos integrates to give sine, so 4 cos x will integrate to give 4 sine x, and then there is a plus c. You try the one on the right. Okay, folks, so integral of 5 sine x minus 3 cos x is minus 5 cos x minus 3 sine x plus c. Last one. So integrating algebraic fractions turns out to be a major problem in A-level maths. The strategy to use where you just have one term on the bottom of your fraction and more than one term added or subtracted on the top is to split this into separate fractions, simplify them if necessary, and then integrate term by term. So if I wanted to integrate 4 plus 3x over x squared, I would first of all split this into the integral of 4 over x squared plus 3x over x squared. And then 4 over x squared, I can rewrite as 4 lots of 1 over x squared, so that's 4x to the minus 2. 3x over x squared, you can cancel x from the top and bottom, and that becomes 3 over x, which I'm not going to write as 3x to the minus 1. I'm going to integrate that because I know how to integrate 1 over x. So the first term, increase the power by 1, it's minus 1, divide by the new power to get minus 4x to the minus 1. 3 over x is 3 lots of 1 over x, which integrates to give 3 ln mod x plus c. Okay, folks, pause the video, have the go at the one on the right. Okay, so this is 5x squared over x cubed minus 7x cubed over x cubed, which simplifies to give 5x minus 7, which integrates to give 5 ln mod x minus 7x plus c. Okay, next bunch of questions. There are here 3 definite integrals where I'm asked to show that the value of an integral is given by a certain amount. Show that means you have to show significant working. So I'm going to deal with the integral from 0 to 2 of 3e to the x plus 4x. And what I think I'm going to do is divide the rest of this in half. I'm going to go down and then across to the other side if necessary. So the integral of 3e to the x is 3e to the x. The integral of 4x is increase the power by 1, so that's 2, divide by 2, it is 2x squared. Put it in a square bracket with a 2 and a 0. So what that means is that is going to be 3e to the power of 2 plus 2 times 2 squared, take away 3e to the power of 0 plus 2 times 0 squared. By the way, in first year integration questions, if you were doing integrals that started with 0, actually you almost didn't have to bother putting in x is 0 because the answer was 0 anyway. This will not be the case in the second year. So what does that give me? Well, the first term is 3e squared plus 2 times 2 squared. Well, that is going to be 3e squared plus 8. Take away the second term, 3e to the 0 is 3 times 1, which is 3, and 2 times 0 squared is just 0. So that clearly simplifies to give 3e squared plus 5 as was required. Second one, the integral from 1 to 3 of 4 to the x minus x to 4. I've got to show that's given by this horrible looking expression here. So let's do my integration. So 4 to the x integrates to give 4 to the x over ln 4 minus x to the 4 integrates to give 1/5 x to the 5. Put it in square brackets with a 3 and a 1. So what does that mean we have to do? We have to do 4 to the power of 3 over ln 4 minus 1/5 times 3 cubed. And then we take away 4 to the power of 1 over ln 4, take away 1/5 times 1 cubed. What's that going to give me? Well, 4 cubed over ln 4 is therefore 64 over ln 4. Take away 1/5 times 3 to the power, sorry, that should be a power 5, and that should be a power 5 there. That's my mistake. 1/5 times 3 to the 5 is 243 over 5. Subtract from the second bracket, 4 to the 1 is just 4 over ln 4 minus 1/5 times 1 to the 5 is just 1/5. Now, if you collect that term and that term, they have a common factor on the bottom. If you subtract the tops, you will get 60 over ln 4. And then minus 243 over 5, take away a minus is add on 1/5, does give 242 over 5 as was required. Final one, folks, I'm asked to show that the integral from pi over 6 to pi over 2 of 5 sine x is given by this exact expression here, 5 root 3 over 2. So this is the area under the graph of y equals 5 sine x. Between two x values, it is highly likely that in such a question, the x values will have pi in them because they must be angles measured in radians. So what does this give? Well, if you integrate this, you get sine integrates to give minus cos. So this is going to integrate to give minus 5 cos x between pi over 2 and pi over 6. So that means minus 5 cos pi over 2 take away minus 5 times cos of pi over 6. Now you can use your calculator a little bit to help you here. Menu 1. So if you do cos of pi over 2, now your calculator must be in radians mode here. We are absolutely, anytime we do trig differentiation or integration in radians, if you do cos of pi over 2, our calculator will happily tell you the answer is 0. So consequently, this first term is minus 5 times 0. Take away the second term is minus 5 times. If you do cos pi over 6, I'm just going to go back and delete that 2 and turn it into a 6. You get 5 root 3 over 2. Now, clearly, the first term is just a 0. A negative times a negative is a positive. So that is indeed 5 root 3 over 2, as was required. Okay, guys, one more example. Then there are some exercises you can do. So this one says, show that the exact area bounded by the curve y equals 2 plus x squared over x and the x-axis, and the lines are x is 1, this point is 1, and x is 5. So this shaded area here, its exact value is 12 plus ln 25. So I'm going to work out that area. I'm going to show that it has this exact value. Well, the area is given by, let me split the page in half, the integral from x is 1 to x is 5 of 2 plus x squared divided by x dx. You cannot integrate this without, first of all, splitting it into two fractions. So the first fraction is just 2 over x. The second fraction is x squared divided by x, which is x, and this is from 1 to 5. Then, via integration, 2 over x integrates to give 2 ln mod x, and x integrates to give 1/2 x squared. Put it in a square bracket with a 5 and a 1. So this means sub in x is 5, sub in x is 1, and subtract, and you're going to get 2 ln mod 5 plus 1/2 times 5 squared. Take away 2 ln mod 1 plus 1/2 times 1 squared. Okay, let's simplify that a little bit further. So the first bracket, 2 ln mod 5. Well, the modulus of 5 is just 5, so that's just 2 ln 5. 1/2 times 5 squared is 25 over 2. Take away 2 ln mod 1. Well, the modulus of 1 is 1 and ln of 1 is 0. If you're not sure about this, folks, if you do ln 1, it will happily give you 0. So the first term in the second bracket is 0. The second term is 1/2 times 1 squared, which is 1/2. So what does that give me? That gives me 2 ln 5 plus 25 over 2 minus 1/2, well, that's 24 over 2, which is indeed plus 12. And then to get the answer in this form, we can use a law of logs. So if there's a number in front of the log, you can bring it in as a power. 2 ln 5 is the same as ln 5 squared, which is indeed ln 25. So that is my answer there. So guys, you are now in a position to do exercise 1. My strong advice to you is do this as soon as possible, because the next lesson will require an understanding of the basic rules of integration that we have done in this lesson.